Hey everybody, this is Larry. This is day 26 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm as it's loading. Today I did nothing. It's a rest day. Haven't had many rest days. I mean, I had a lot of rest days, but yeah, my body's sore from doing all the squats. Well, my butt mostly, as just haven't done squats in a while, and that always happens. But anyway, not much to add, so let's take a look at today's problem. Yeah, today we have 1749 maximum absolute sum of any subarray. You're given an integer array nums, the absolute sum of subarray nums sub L all the way to R is, okay, the sum of them. Well, the absolute sum of them, okay. Return the maximum absolute sum of any possibly empty subarray of nums. Okay, Yeah, I mean, I think my first intuition is just what is it called again? What is that algorithm called? I forget. What am I blanking out on? My first impression is that algorithm though. The linear one, what's it called? Man, naming things is hard. I could write it from scratch, but I can't name things. But that's actually more important, right? I mean, obviously, maybe not for me because I'm explaining this to you, but or trying to anyway. But if you're doing a contest or anything like that, obviously, knowing how to solve things is more important than the name of things, right? We can know the name of so many things, but it doesn't help us do anything. But yeah, alright. I did not. Okay, well, I'm not gonna lie. I am Googling for it, but what's it called? Because okay, Cadane's algorithm. I couldn't remember the name. Okay, all I did was search for the name, and that's only honestly for your sake because it's a straightforward algorithm. I mean the Cadane's algorithm is actually I don't know why I'm blanking today. Maybe I should have took a break, but Cadane's algorithm is one of those things that's a little bit awkward, a little bit hard. I think the thing about Cadane's algorithm is that there is this. Like I think the thing that I worry about with Cadane's algorithm is that people just memorize it, right? And it is pretty. I don't know how often it comes up. It is somewhat useful when it does come up, but it doesn't come up that much, except for maybe in competitive interviews. It's a little bit awkward. I think the way that I like to go over Cadane's algorithm is by saying that it is a dynamic program problem. You might not realize this necessarily, but in any case, yeah. I thought it would be more contribution E like we did yesterday, but I mean I think it's just Cadane's algorithm. The thing is that with Cadane's algorithm, well. Okay, let me step back a second. Right? I think the absolute value is kind of like one of those functions that that could be intimidating because you don't know what you're looking for, right? Or that is tricky because as a function, it has this like weird pairwise thing, right? And okay, maybe I will draw real quick. I mean, it's nothing like that rocket sciencey. Or rocket surgery, but basically, given something like that, and I'm not even thinking of my drawing, but you can imagine like the absolute value graph looks something like this, right? And this is just a function, right? I don't know if this is clear to people at home, but basically you have maybe I need to. That's the x is equal to 0, right? And then this is the y-axis, right? And that's kind of the graph for absolute value, right? And this function is, as you can see, it's not differentiable through the entire plane because of at 0 and so forth. It is a little bit awkward, and sometimes it's tricky to kind of optimize for, right? When you do about maximum and stuff. The one thing that you can kind of realize from looking at this though is that first is that it is linear, right? Still. And in fact, it is piecemeal linear. I almost said piecewise, but that doesn't even make sense. Piecemeal linear, right? Because then now the idea here, and it comes up, and this part, maybe for this problem, it's a little bit of an overkill, I admit. but it does come up in more difficult problems, so that's why I'm spending time on it. Is that, you know, you have basically two functions, right? You have this thing where was it y is equal to negative x, right? Oops. And then you have x is equal to y, right? Or maybe I don't know what's the convention. I guess the convention is actually x is equal to y is equal to negative x is fine, right? Maybe negative y is equal to, I don't know, whatever, same thing, right? Then now basically now you have two functions, and that's kind of the way that I would attack a problem like this one, where okay, you try to maximize this thing, right? And then the idea then will be that okay, we have this absolute value, you're trying to maximize this, then now you just try to maximize two functions, right? You maximize this where it is well, just maximum, right? Just regular maximum, I suppose, where it is positive, and then you maximize this in a way, minimizing this, but have negative, right? So where the value is inside is negative. I mean, like I said, for this problem, for right now, I think this is hopefully easy to follow and easy to kind of reason. But the reason why I'm a little bit slow and elaborate about this is because this function comes up a lot in a lot of random places, and when you are able to break them down, then you can ask yourself different things about it, right? Like, I mean, for this one, the different things is not that tricky, as I keep saying, but for similar problems, you can imagine that it could be actually kind of tricky, but you can do case analysis on them, right? And I think that's kind of the key thing. Like, yeah. And here, the case analysis, again, is pretty simple, right? Is that if this sum is positive, then we just want to take it. Otherwise, it is easy to maximize the negative value. It is just to minimize the positive value. I guess not even that way. But you just take a negative of all the numbers, and then you multiply by -1, and then you multiply by -1 again, right? Or something like that. So pretty straightforward. So we can, and you can write this in a number of ways. So yeah, so maybe right? And then now we have, how does that go again? Best is equal to 0. Keep in mind that we can take the empty array, so best is equal to 0 is fine because we are at least taking, or if you take 0 elements, it's gonna be 0, and that's better than taking anything. Though for this one, you probably, yeah, you can take anything anyway. But yeah, yeah, and then now it is just right? If current if current is less than 0, then current is equal to x, and then yeah, and then we want to do best is equal to max best of current, and then we just return best, and that's contains, right? You can kind of reason this out. I'm not going to spend that much time on contains today. I don't think that contains could be interesting, but just not for me for today. Keep in mind that this is dynamic programming. You kind of figure it doesn't look that way because it just sometimes dynamic programming, especially the space optimized version, could look very simple, and you kind of reason your way around it. But maybe if you think about it as dynamic programming, it's a little bit more straightforward, right? And you could kind of write this recursively as a result, right? Which allows you to do different things when you vary things. Anyway. Yeah, so then now it's just either we do contains on nums, or so we take this one, or as we said, the max of the negative version of this, right? So contains of what, negative x for x in nums or something like that, right? Maybe I have to convert it to a list. I'm really bad at generator stuff and syntax sometimes, but you know. And apparently that's not right. All this set. Oh, I'm dumb. Because now this will return you a negative answer, right? So we have to convert it back. I mean, I said it before, but okay. Well, apparently that's not enough. Dun, dun, dun. Did I mess something up? I mean, clearly. No, that should be. No, I don't think this is necessary, actually. Or shouldn't be. I did say it, but well, do I? No, -1. No, it shouldn't be. Then why am I doing it wrong? List of negative x for x in nums, right? Oh, I'm just being dumb because I don't use nums. Or I named this array, but I use nums here. That's why. So okay. All right. Well, it's still wrong, but is it now? Do I? No, that should be good. Well, I said a lot about how straightforward it is, and then I just kind of messes up. I don't know. But okay, so it's 3, right? Let's take a look at 3 first. There's one number 3, so that's right. So 6. Let me double check that I am typing everything correctly this time. That's pretty bad. I mean, I feel like I'm just, I don't know. I don't think I'm very good at talking and coding at the same time, which kind of is why I've been kind of worse and worse lately. It is what it is. So current 5, 4, 8, right? Like, how does this, like, I don't. Oh, I had to click and read more. That's why I was confused. Okay. -2. Yep. Oh. Huh. I guess I did mess this up because I was going too fast. Yeah, that makes sense actually. Because basically the idea is that, okay, yeah, for every number, if it is negative, then you don't want to take it to start a new streak. You just take it here, right? Oh, I guess here's more accurate, right? Yeah, then you want to end the streak because it's negative, because you're going to always take 0 elements. I think the other variation is if you're forced to have 1 element. But even then, that's a little bit off because that still should have given the right answer. So I have to really think about what I want to do. I am really bad at the 1 element version, even though I don't need it for this particular one anyway. Let's give it a quick submit. I mean, that's fine. I'm still trying to think of the 1 element version. Because that should not make sense. I guess the 1 element version would be something like this, right? Then now you're forced, this would have at least 1 element when you start a new one. I think that's fine then. But I mean, I wonder if that, I mean, I think for this problem, 1 element should be the same. I'm just curious, yeah. And the reason why it's the same is because it never makes sense to take 0 element, which is why it's very easy to kind of like I just want to bring up, because it's very subtle difference between the 1 element version and the at least 1 element version and the empty version, right? And I'm kind of bad at that, honestly, because I don't find contains that useful. So the 2 or 3 times that it comes up, I feel like I'm bad because it just, I don't know it that well. But for this problem, the 0 and 1 element version has no differentiation, because in the 0 version, the value is just 0, and then the 1 element version is always positive, so it's always going to be better than the 0 or equal to, I guess, if you have a 0 element. So that's why it doesn't matter, which makes it like easy to kind of make mistakes. And somehow I chose the way that was wrong anyway, but yeah. Anyway, that is all I have for this one. Let me know what you think. I mean, this is pretty linear time, kind of constant space. I say kind of because I guess I technically made this linear by using this thing, but you could do things about it. I mean, I don't know. I mean, if you really want to keep it linear, you could have I don't know. You just do something like I don't know, like m is equal to 1, and then maybe something like, how did the 3 get here? Something like that, and then we just, I don't know, oops, m, right? So that would probably work unless I made another mistake somewhere. Yeah, so that now I made it linear time constant space with no weird ifs, you know, caveats. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, take good mental health. The hardest part about this was remembering the name of Cadane's algorithm for me, I suppose. And well, and I made silly mistakes, so I don't know. But yeah, have a great rest of the week, everybody. I'll see y'all later and take care. Bye bye.